These are the notes for AP Calculus on the topic of finding the area between two curves. So, on this one we have three functions, f of x, g of x, and h of x, which are already graphed for us. And we're going to use our graphing calculator on all of these problems on notes for today. So let's go ahead and enter these in, and again I'm going to show on two different calculators, both the TI-84 and the TI-Nspire. So let's look at the 84 first. And after you turn it on, just go to y equals, and we'll enter the first one is 5. Arctangent is, on your calculator, looks like tangent to the -1 there, of x. Use the xt theta n button. Close parentheses, because notice the 3 is not inside there, and then plus 3. And the second one is 3 cosine of x. Close parentheses, and then plus 3. And the third one for h of x is x minus, make sure you use this minus, not the negative here, just for out of front, 5, close parentheses, squared, and then plus 4. And let's change our window size also. So on this one, let's make x minimum -1, x maximum make that 10, see that 10, and then y minimum, let's make that -1, that's where you use the negative out with parentheses out front, and let's make that 11, and then we'll graph it. You can see it graphs in the order we typed it in, so there's f of x, there's g of x right there, and there's h of x. So let's go ahead and label those on our graph here. So this one was f of x. G of x, and h of x. And let's go ahead and figure out part A with this calculator, and then we'll look at the Nspire also. So for part A, it says find the area of region R. So, see, region R is this little area right in here. So first let's draw a representative rectangle there. So this represents an infinitely thin rectangle, and the width of that rectangle is change at x dx. So remember, for the area between two curves, you get what you integrate is the height of the rectangle, which is the top one minus the bottom one. In this case, that's g of x on top and h of x is on the bottom. But what we need to use our calculator to find is those points of intersection. So that one, the x coordinate I'll call A, and the x coordinate of that point of intersection I'll call B. So we can set up our integral to find the area. We'll figure out here, using our calculator, what A and B are. And then once we do that, the integral will be from A to B. And then remember, we saw the curve on the top here, that's g of x. The curve on the bottom is h of x, so that's what we're going to integrate. G of x minus h of x. That gives you the height of each rectangle times dx. That's the width of each rectangle. That gives you the area of each one. We're integrating all those areas from A to B. So now we need to find those points of intersection, A and B, using our calculator. So to do that, you just go second and then calc of the trace button, and then number 5, intersect. And here, since we have 3 curves entered in, you have to be careful and make sure you choose the correct one. So we're trying to find this point of intersection right here. And that was, if you look at the graph, that's where h of x and g of x intersect. So when it says first curve, it's not y1, that's f of x. So you hit the down arrow, first curve is y2 or y3. Those are the two that are intersecting. There's g of x right there, hit enter. Second curve, you want to choose y3, which is h of x. So the calculator needs to know which 2 curves are intersecting it. And then your guess, either type it in or move the cursor close to that point of intersection. You can see there's our x-coordinate of our point of intersection, which is what we're interested in, which is 5.053. And then remember, we want to store this in our calculator also. So then you go second quit out of here. And some of you guys may have to go second A and S, but on the 84 here, it automatically puts that when you hit the store button, and then alpha A. So now that's in our calculator is the constant A. And we can do the same thing to find our other point of intersection B. Second calc, number 5, intersect. First curve, again, this point of intersection is also g of x and h of x that are intersecting there. So we still don't want to choose y1, hit the down arrow, choose y2, second curve, y3. Enter, and then guess this time, either type in your guess or move the cursor closer to this point of intersection. And then enter. And you can see B would equal 6.406. And let's store this in our calculator. So go second quit, store alpha B. And now we're all set to integrate this. So we've got our integral all set up here. So let's go ahead and use our calculator to integrate it, see what this equals. So we can just go hit the math button, go down to F9 for function integrate. And what we want to integrate is g of x, which is y2. So hit vars button, variables, y variables, function, and then y2 minus variables, y variables, y3, because that's what we want the calculator to integrate. That's what's inside our integral. Then remember the format is you hit comma and then the variable, which is x, comma, your lower limit we stored as alpha A. If you didn't store it, you'd have to type it in, and then comma, upper limit alpha B, close parentheses. And we get 0.91574. You can write down all the decimals there, but really you want to make sure you're accurate to 3 decimal places. So if you round that off, that would be 0.9 to 3 decimal places, 0.916 or 0.915. You can also truncate it and just drop everything off after the 3rd decimal, after the thousandths place. Either one would be considered correct on the AP test. Alright, now let's look at the same thing. We've got this all set up using the Inspire calculator. So, Inspire, let's go ahead and enter these in. Let's document, let's insert graphs, and let's type these in. So we've got 5, all the trig functions are here. So there's arctangent. Here we have the x is down here, x plus 3 hit the down arrow. Let's enter the other one. This second one is 3 cosine of x. Whoops. Plus 3. And then x minus 5 squared plus 4. Okay, so there's the 3 graphs there, and then let's change our window size. So menu, window, zoom, window settings. Let's make our settings the same. So -1 to 10 on the x min and max, and y minimum, let's make that -1 to 11. Okay, so there's our graph there. And define our points of intersection. And you go to menu, analyze graph, intersection. So it says graph here, so you want to know which graphs are intersecting there. So it's asking us which one, so choose F2, and the second graph, F3. And then lower bound, choose something to the left of this point of intersection, upper bound to the right of it, and there's your point of intersection right there. So highlight it, and then hit the bar button for variables, and store variable, and then you can choose A. Enter. Now it's bolded, so you know it's stored in there. And let's go ahead and find our other point of intersection the same way. So you go menu, analyze graph, intersection. Again, choose your curves by clicking on them. So it's F2 and F3. Lower bound, choose something to the left of that point of intersection, upper bound to the right of it. And there's our second point of intersection. And store as B. And now we've got that on the graph there, so now you just want to go document, insert, calculator, and then right here to integrate that, there's the integral symbol there. So the integral would be from A tab B, and hit the tab, and then we've got, you can access your functions right here, variables. There's, we want F2, there's g of x, 2 of x, and then minus F3 of x. And then the variables dx. Then enter, and you can see we get the same answer there. Okay, let's go on to our next region here. Next region says find the area of S. Region S, which is bounded by the y-axis. So for region S, you can see it would keep going this way, but it says it's bounded by the y-axis, so it starts right there and stops right there. So we can draw our representative rectangle in there. X. And we don't need to find where it intersects here because it just starts at the y-axis, which is x equals 0. But we do need to find this point of intersection, which I'll call point C. So let's go ahead and set up this integral here. So for this area, it's going to be the integral that starts at the y-axis, which is 0 to C. So let's leave some room here to write down what C is. And on this one, if we look back at our rectangle here, you can see the function on top is this one, which is g of x. At this time, the function on the bottom is this one, f of x. So it would be g of x minus f of x inside the integral. All times dx. So let's go ahead and use our calculator to find that point of intersection C. So again, I'll show you on the 84 first. So you go to second calc, number 5, intersect.
first curve. This time, the points that curves that are intersecting are f of x and g of x, so you would choose y1. And second curve, y2. That's f of x and g of x. And guess, now if you don't want to move the cursor, this could take a long time hitting the left arrow, you can type in your guess. Let's say my guess is 1. You can just type in x equals 1. And it takes you right to that point of intersection, which is 0.5580. Two, 3, 1. And I'm going to store it in our calculator. So second quit, store alpha c. And then we can use our calculator to go ahead and integrate this one. So it'd be math, function integrate, number 9. This time we want g of x minus f of x, so that's y2 minus y1. So variables, y variables, y2 minus variables, y variables, y1, and then comma lower limit, the variables x, comma the lower limit is 0, comma the upper limit this time is c, so alpha c. And we get this one is 0.846. And here, whether you round it or truncate it, it doesn't round up, so. And again, I'm going to show you quickly on the Inspire how you do the same thing. So on the Inspire, let's go back to the graph here and find this point of intersection here. So go menu, analyze graph, intersection. This time we're going to choose F2 and F1 as our two graphs. Lower bound to the left of it, upper bound to the right of it, and then store it in your calculator. So highlight it, and then variables, store variable, and then put in C. Okay. And then go back to the main calculator screen, and then we want to integrate. Lower limit 0, tab, upper limit C. And this time it's F2 minus F1 because it's g of x minus f of x. So F2 of x minus F1 of x. And you can see you get the same answer that way. Okay, let's look at our next region. The next region we're finding is the region T, which is bounded by the x and y axis. So region T, so we've got the y axis and x axis is bounded. What's different about this one is when you draw the rectangle in there, it's not always between the same two curves. You can see if we draw a representative rectangle right here, it's between f of x and the y-axis there. But notice if I draw the rectangle over here, it's between g of x and the y-axis. And where that change happens, notice, is right at point C, which we've already found. So right there is where that change happens. So because of that, to find this area, we actually have to split it into two separate ones. So we also need to know what that is D right there. So let's see how we set this up here. We already know what C is.
find D. And first integral would start at 0 and stop at C. And on this one, it would just be f of x is the one on top minus, the one on the bottom is just the line y equals 0. So it's like f of x minus 0 is just f of x. Dx plus second integral would be from starting at C and stopping at D right there. We'll find in just a second. So from C to D. And on this one, the one on top is g of x minus the one on bottom. So g of x minus 0 is just g of x. Minus dx. So we'll have to evaluate each of these and add up the integrals. And to find D, there's a couple different ways you can do it. One way, you could enter in as your next function just 0, and then find where it intersects with it. That's one way of doing it. Or, it's a little faster if you use another function on your calculator. Find the zeros. So, the 84 first. What you can do here, to find the zeros of that, notice that's just g of x. So what you'd have to do is de-highlight y1 and y3. So it's only g of x we're looking at. And then go second calc. The number 2 zeros. On some calculators it may say roots or roots. Root or roots. And then find the zeros of it. So then left bound, choose something to the left of that 0. Right bound to the right of that 0. And your guess, something in between there. So there's your 0, and now look at that number, see if it looks familiar. Got 3.14159, well, that's just pi. And you can see that makes sense because if you plug in pi into g of x right there, cosine of pi is -1, times 3 makes that -3, plus 3 makes it 0. So it is exactly pi. So because it's exactly pi, we don't necessarily have to store it on calculator. Write that down. So it's just pi. So really, just make that pi. Alright, so let's use our calculator to evaluate this now. I'll do the 84 first. So put out of here. We don't need to store pi, it's already in our calculator. So I go math. You can do this all at once really. Function integrate. The first one is just f of x. So that's y1 in our calculator. Minus, sorry, not minus anything this time because it's like minus 0. So comma x, comma lower limit is 0, comma the upper limit is c. See, and then plus integral. This one is just g of x, so that's y2. Comma lower limit c, comma upper limit pi. On this calculator, pi is right there. And, oops, I forgot the x. So what you can do if you don't want to have to retype it is go second INS for insert. And then instead of overwriting like it normally does, it will insert it right in there, comma. And then you have to retype the rest of it there. And then hit enter. And we can see we get 8.5786. So here's where it would round up, so you could write that whole thing, or if you wanted to round it, write that, or just truncate it and just count it after 3 decimal places. Either one would be considered correct on the AP test. All right, let's look at the Inspire for the same problem now.
So on the Inspire, if you go back to the graph here, to find the zeros, all you have to do is go Menu, Analyze Graph, number 1, 0, and then you just click on graph F2, lower bound to the left of it, upper bound to the right of it, and there it is right there. And again, you can see that's pi, so we don't need to store it in our calculator. And then just go back to the main calculator window, and then you would just integrate. First one was from 0 to C, and this one was just f of x, so you just go variable f1, is our f of x, dx, and plot, whoops, tab there first, and then hit the right arrow first, and then plus another integral. This one was from C to pi, and on this calculator, pi is on this button here that says pi, and this was g of x, so f2 of x dx. And you can see you get the same answer that way. Alright, let's look at our next region. So now we're finding the area of region U. So if we go back here, we can see here's region U, and you can see, well, region U, similar to region T, isn't always between the same two curves. You can see, if we draw the representative rectangle right here, it's between f of x and g of x. But if I draw the representative rectangle right here, now the one curve on top is now h of x and then minus g of x. And you can see where that change happens is right here. So we'll have to find that point of intersection, which I'll call capital B. And we've already found C and A, so the first integral will be from C to E, and the second integral from E to A. Okay, so let's go ahead and set this up here. So we need to know what E is. We'll find that using our calculator in just a second. So it will be from C to E. And if we look back at this one, the graph, we can see the one on top is f of x minus the one on the bottom is g of x. So f of x minus g of x. We'll go inside the integral. That gives you the height of each rectangle times dx is the width, turns it into area, and then plus integral from E to, if we look back at our graph, region stops at A, and on this one, the one on top is h of x minus g of x. E to A, h of x minus g of x. Alright, so let's just go find our point of intersection E. So on 84, go back to y equals, let's re-highlight all of these again, so we have all three graphs again in our calculator. We only had to de-highlight them when we were doing the 0. So then, second calc, intersect, and at point E right here, notice the curves that are intersecting are f of x and h of x. So first curve, you can choose y1, that's f of x. The second curve, don't choose y2, because it's h of x we want. So hit the down arrow and choose y3. And then your guess, again, you can either type it in or move the cursor close to that point of intersection and hit enter. So we get 2.740. $6,524. Okay, let's store this in our calculator. Quit, store alpha E, and then let's go ahead and integrate this. So math, function integrate. First one is f of x minus g of x, so that'd be y1 minus y2. And then x on the lower limit is c, upper limit e, plus the other integral is h of x minus g of x, so that's y3 minus y2. And this time, after we do the x, the lower limit is e, comma, the upper limit is a. Now we get 21.2078.
So again, this is one where you could round it up to 208 or leave it 207 either way. You can write the whole thing, that's fine also, as long as you're accurate to at least 3 decimal places.
Now let's do the same thing on the Inspire. So on the Inspire, let's go back to our graph here, and we need to find this point of intersection. So again, you'll menu, just analyze graph, intersection, and the ones that intersecting are F1 and F3, so click on those, lower bound to the left of it, upper bound to the right of it, and then highlight that and store it as E. Now notice this E is our constant. If you want the E that represents the Euler's number here, that's from this menu right here. That's that E in bold. So you know the difference between those. Okay, so then go back to the calculator menu and set up our integrals. So the first one was from, let me just double check that. C to E. So it'd be from C to E. And this was f of x minus g of x. So that's f1 of x minus f2 of x. X, right arrow, and then plus second integral was from E to A, and this was h of x minus g of x, so that's f3 of x minus f2 of x. And we get the same answer that way. Right, let's look at one more region. This one, it says find the area of region V. So let's go back and look at region V and see where that is.
So region B is right in there. So there's a couple of ways of doing this one. One way is you could split it up. Now notice if you split it up into various rectangles, here it would be between f of x and g of x, or f of x and h of x. And then at point A, you could split it there, and then it would be between f of x and g of x, and then split it again at B, and it would be between f of x and h of x. So you could do that and use 3 intervals. However, there is an easier way of figuring this out, especially since we've already found the area of this region R in the first part A. So to find this one, the easiest way would be to find the area of this entire thing, including region R, and then just subtract the area we've got from region R already. So just need to find this point of intersection, which I'll call F, and then we can set it up that way. So F equals, and we can just do the integral from E to F. And if we look at this one, if we do the entire thing, the one on the curve is, the one on the bottom of the rectangle there is h of x, so it'd be f of x minus h of x. X, we'll take that and then just subtract area of region R, which we already got. Mark it. So let's go ahead and find that last point of intersection, F. Intersect. This time at point F, you can see right here that it's f of x and h of x intersecting. So first curve would be y1. Second curve, not y2, would be y3. That's our h of x. And your guess, again, you can move the cursor over there, or you can just type in, if I want to guess, maybe it's over here at 8. I can just type in 8. And then my point of intersection is 7.488. Zero, 0.62. So make sure you write it on paper and store it in your calculator. If you don't write it on paper, then there'll be no way for anybody else to know what you stored in your calculator as it. So it's important you write it on paper as well. So second quit. Store alpha F. Okay. And then we can get our calculator to integrate this for us. So math should integrate. This time it's f of x minus h of x, so that'll be y1 minus y3. Then comma the lower limit x, whoops. Sorry, x, and then comma the lower limit is e, comma the upper limit f, and then you can subtract. Well, let's just put down what this is here. 18.626. $60961 minus, if you look back, our area of region R was point 91574.
So in your calculator, you can just have that do it for you. Minus 0.91574. So you get
17.710 or 17.711. If you'd rather that or just might be.
Now let's look at the same thing on the Inspire. So we want to find that point of intersection over here. So again, menu, analyze graph, intersection, F1 and F3, lower bound to the left of it, upper bound to the right of it. And there it is right there. And store it as F. And then go back to the main menu here. And then I'll integrate from E to F. This was f of x minus h of x, so f1 minus f3. And we can see we can get the same thing, and if you subtract the area we got from part 0.91574, see we get the same answer. And that concludes the notes on the topic of area between two curves.